Good evening, everybody. This is Lorenzo Perella, Physics 116, Clark Wellman class. Excuse me there, just had some orange soda, but you don't need to know that. Anyway, today we'll be going over Quiz 8, which is a continuation of optics in the eye. For this first part, we have a far-sighted person's right eye with a near point of 1200 millimeters in front of the eye. To enable the eye to see an object at a normal near distance of 25 centimeters, what is the power in diopters of a contact lens needed? And the same idea is to be applied for when there is eyeglasses that are 15 millimeters in front of the eye. For our calculation for this, we first have to convert millimeters into meters. In this case, that is 1.2 meters. And that knowing that with contact lenses, there is no separation of any significant difference in distance between the eye and the lens. So we don't need to calculate a difference for the DI, which is the distance of the image. In this case, since it's farsighted, we have to remember that the DI is a negative value for power for when we're trying to decrease the amount of power that the lens is focusing out, because when you're farsighted, you're able to see something far away, but you have trouble seeing things close by. So the power here is 1 over the distance of the object plus the distance of the image, which I think was 1 over the focal length. But in this case, we're just figuring out power, which in that case is 1 divided by 0.25 meters plus 1 over negative 1.2 meters. This equals 4 diopters minus 0.833 diopters, which gives us a new power of 3.17 diopters. Now, when we have lenses, like an eyeglass manufacturer, that's 15 centimeters in front of the eye, we first convert 15 millimeters to 0.1015 meters, which is also 1.5 centimeters. And we have to make now a new distant image because there's a little space between the eye and the lens. To get that, we take 1.2 meters negative plus 0.015 meters, which is negative 1.185 meters. And then for the distance object, take 25 centimeters minus 1.5 centimeters to give us 23.5 centimeters. And then we convert these both to meters. Our power is equal to 1 over 0.235 meters plus 1 over negative 1.185 meters. This gives us a new power of 3.41 diopters, which can show that when you have prescription lenses, they offer a greater power than contact lenses. This being that when you put distance between the eye and the lens, you create a smaller value for the distance. The distances both of the object and the image, and then we're looking at the inverse, so that creates larger numbers. Okay, and the way that this works is that when you have someone who's farsighted or myopic, their eyes are diverging and they have too much power in them. So when something's close by, it all comes blurry. With these corrective lenses, it allows the light to converge quicker onto the eye and allow the person to see the object more clearly. And then if you saw these on a contact lenses, these would be the power that you would see on the side, as well as this one for the manufacturer of the eyeglass. Okay, this has been Lorenzo Perella for class 115 for Physics 116 with Clark Wellman. Hope you enjoyed this video. Have a wonderful evening.